So in Chapter 9, one of the goals is to teach you how to analyze projects for risk, and we looked at the break-even net present value. We discovered that the company must sell 5,632 units the first year, and they had originally expected to sell 27,000 units the first year. So even if they're wrong about their expected unit sales in year one, they have a big margin for error before this project hits a negative net present value. So based on the break-even NPV, I would think that this project, even though it's risky, is worthwhile to pursue. Like if I had only thought I could sell 6,000 units the first year, and my break-even NPV said I needed to sell 5,600 units, then I'd be a little leery, because even though at 6,000 units the project would have a positive NPV, since this is an expected value and not carved in stone, I'd be a little worried that perhaps it wouldn't occur and I'd actually end up undertaking a project that lost me money. But I'll put that back to 27,000. Another way to analyze risk is to do something called sensitivity analysis. And with sensitivity analysis, what you do is analyze variables that are uncertain and see the impact on the net present value or the IRR or even the modified IRR of those uncertain variables. So the first step is choose your uncertain variables that you want to analyze. So that could be things like the unit sales, the unit price, the variable costs per unit. It could even be the length of the project. So I expect this project to last 3 years and then I'm going to sell it, but maybe I'll hold it for 6 years before I sell it, or maybe it will end at year 2. I'm not going to adjust that one for this demonstration, but you could program your spreadsheet so that the length of the project could adjust. I don't even know for certain what my tax rate will be, so that could be something I would look at. I don't know exactly what my discount rate will be, because it's going to be the cost of raising the money to buy the project if I choose to do it. And since I haven't yet raised the money, I don't know exactly what it's going to cost me. So that discount rate can be uncertain as well. And if you remember, when we calculated the terminal cash flows in cells E25, we assumed a constant growth rate of 2% from here to infinity, but maybe that growth rate could be 3% or 1%. So, and because this is such a huge number, it's having a very large impact on our project's net present value. So I definitely want to see if my project is really sensitive to that growth rate. So I'll type in the constant growth rate as another uncertain variable. Next, you subject each uncertain variable to uncertainty, essentially. And a lot of times what they'll do is they'll say plus or minus 10% variability, 20% variability, and 30% variability. So what if my unit sales are 10% higher than I thought, 20% higher than I thought, 30% higher, and then also 10, 20, and 30% lower than originally expected? So I'm just going to choose some of the uncertain variables. I'm not going to do them all. I'll do unit price, variable costs per unit, and unit sales. And then I'll also do that constant growth rate, because this terminal value is so high that it has a huge influence on that NPV, so I'm just curious to see what will happen. So now I would go, what if this is 30% less than what I originally thought, and I would reduce the unit price by 30% and input my net present value here. And what if it's 20% less than I thought, 10% less, 0% less, so they call that the base case. Sometimes I type in base case, so I'll do that here. And then 10% more, 20% more, and 30% more. Excel can actually do this. It has something called a scenario manager, but I find it actually just as quick, if not quicker, to do this myself. So what I'm going to do is create a cell that I'm going to call the factor. And first I'm going to make it minus 30%. And then I'm going to go to the cell that I want to adjust, so unit price, and that's here in row 14. And I'm just looking at my formulas here. If I change this cell, it doesn't impact cell D14 because I didn't create a link in D14 to C14. I just typed in $3.50 in all three of these cells. Well, I want to try to be efficient, so since I want the same price in each of these three cells, I am going to link year 2's unit price to year 1. And I will link year 3's unit price to year 1. So now if I change this from 350 to 4, it changes all the years after that. That will just make my life a little bit easier. So now what I'm going to do is in year 1 for the unit price, I'm going to put an equation, and I'm going to multiply it by 1 plus this factor. Since my factor says minus 30%, 1 plus minus 30% is 70%. So it's basically taking the $3.50 and multiplying by 70%, essentially saying if the price is 30% lower than your original $3.50, that gives me $2.45. And when I changed year 1's price, year 2 and 3 changed, and my MPV changed. So now I'm just going to pop that NPV, Control C, and paste values here in the minus 30%. I want to paste the values because when I change this factor to minus 20, it's going to change this number, and if I pasted the formula, it would change it here. So instead I paste the values. And look to make sure your numbers make sense. If my unit price is 30% less, what's going to be happening to all these inflows? They'll be dropping, and so my MPV should have declined, and it did since it was originally 400,000 plus. So now what I'm going to do is just split my screen to make this go a little easier and faster. And I can change this to minus 20%, copy my NPV, and paste values. Minus 10%, copy that NPV, and paste values. And I will finish the rest of it when the video's not recording, because I don't want y'all to have to watch me laboriously go through all of these, but I want to show you what to do next. Once you've done all of your unit prices, so you've completed this part of the table, go back to your $3 or your unit price for year 1 formula and just pop it back to the original $3.50. So now we're back to our original $404,000 NPV. Now go to your variable cost per unit, and I didn't actually program that in, not on a per unit basis. It's built into this formula right here. Well, in hindsight, I should have put it on a separate cell. So what I'm going to do is go variable costs per unit, and that would be $1.25. And here I'm going to say it equals the previous year, and I can just copy that across, and it will set equations in years 2 and 3 variable cost cells. And I've only typed it directly into year 1's variable cost. And for my total variable cost, now down here I'm going to create a link. So I would just replace this $1.25 with a link to cell C17. And I should be able to copy that across and it works fine. So now if I change this to $1, both of these change, all these cash flows change, and everything below it changes. But I'm going to pop it up to $1.25 again. Double check, make certain I've got my unit price back to the $3.50. I'm going to change this to minus 30% and link it to my variable cost in the first year. So my equal $1.25 times 1 plus that factor that I have up here. So if variable costs are 30% less, they wouldn't be $1.25, they'd be 88 cents a unit. And so that, and it's a cost, so that means my inflows will rise since the cost has decreased, and my net present value will go up. So now I can copy that net present value, go to the minus 30% cell under variable cost per unit, and paste text. Make this 20%, copy that again, paste it in the minus 20% one. Then and again, I'll finish the rest of this table later. Then do the same thing to unit sales, but change your variable cost per unit back to the original $1.25. Change your factor back to minus 30%. And now I'm going to unit sales. Since this unit sales in C13 is annual unit sales, and it's got an equation in it, I'm going to change cell C12, the daily unit sales. It doesn't matter if I do it on a daily basis or an annual basis, so I will choose the daily one. I'm setting an equation. I'm going to start with daily sales, 75 units, and multiply by 1 plus that factor in G1. So if sales are 30% less, they wouldn't be 75 units a day, they'd be 53 units a day. And I'm keeping formulas in D12 and E12 because they're based on the anticipated growth rate of 20% and 25% over the next 2 years. But if unit sales are not the base case of 75 units a day, and instead they drop by 53 or by 30%, and drop to 53 units a day, my NPV is expected to be 250,000. So I copy that and paste values into the unit sales minus 30. Then change it to minus 20, copy, paste that to minus 20. Change it to minus 10, copy and paste that as a value. Then change your daily units back to the 75. And now I want to adjust this constant growth rate in my terminal cash flows. But you can see I just hardwired my growth rate into this formula, and I shouldn't have done that because I can't easily change it with this factor. And I'd like to be able to easily change it with the factor. So what I'm going to do is create a separate cell that has the constant growth rate in it that I can easily change and link it to the proper places in the formula. And I'm just going to do that right here. And so I'm going to replace the 0.02 with a link to this cell, but I have to put plus F25, and I will replace the 0.02 here as well. And that looks good, except it didn't give me the right answer. I probably need to put that in parentheses, and I'm just going to make sure it does everything in the order that I want it to do. There we go. So just adjusting some parentheses. So now if I change this to 3%, it's growing at a higher rate, so it should have a higher present value. And now I'm going to link it and take 2% times 1 plus that factor in G1. Change this to minus 30%. And I'm going to actually extend the number of decimal places so you can see if growth is 30% lower than expected, 2% times 0.7 or 1 minus 0.3 30% is 1.4%. So if growth is lower, this will have a smaller value, resulting in the net present value being smaller. So I'm going to copy that net present value, paste special values. Change this factor to minus 20%. Copy that net present value. Again to minus 10%. Copy that net present value. Now I'm going to take a moment to just finish the rest of this table, doing the base case, which was just my original net present value, and then the plus 10, 20, and 30% for all 4 of those variables. Okay, now that I have completed the table of the sensitivity analysis, a quick glance shows that the net present value isn't negative for any of the variables in the range that we've evaluated. Now normally that's not what happens. Normally, like a project might hit the red in terms of unit price if the price drops below 10% of what was originally expected, or maybe when the price drops below 20% of what was originally expected. So a lot of the times you will see negative values here. The fact that we have not seen any negative values tells us that this project is highly likely to be successful. But rather than presenting the data in a tabular fashion, it actually makes a lot of sense to present it graphically. So I'm going to insert a line chart, and I highlighted, actually I'll do it again, although you could rewind this video, which is kind of cool. I started highlighting in this cell my G11, which was blank, but basically I wanted to take these labels here in row 11, make that the x-axis labels, and use the data in this section of the range that I've highlighted to be my legend. And if you highlight things like that, Excel will automatically take those variables and make them your legend and your x-axis labels. All sensitivity graphs should intersect at the base case, because that was our original expectation. And by looking at the steepness of the lines, I can see which variable has the most influence on the project's net present value. Or another way of saying that is I can see which variable the project is most sensitive to. So the flatter the line, the least or very low degree of sensitivity the variable has. So even though I thought the constant growth rate was going to have a pretty big impact on the project's net present value, it looks like it doesn't, because that line is fairly flat. The project does have a lot of sensitivity to the blue line, the unit price. So if I'm wrong and customers won't be willing to pay $3.50 for it, if they only are willing to pay, let's say, $2, my project's going to be very sensitive to that. So that's what a sensitivity analysis does. It lets you, in this case, visually assess the sensitivity of a project to a particular variable. So the pros for the sensitivity analysis is that it allows a visual assessment of the project's sensitivity to certain variables. It's fairly easy to do as well. And I also think it's easy to understand. But it's got some serious cons. First, I only evaluated one variable at a time. I completely ignored the interrelationships between variables. So, for instance, if I lowered my price, then in all likelihood my unit sales would go up. Or if I increased my price, unit sales would probably drop. If my variable costs rose, then maybe my unit price would go up because I would pass that increase in cost along to my customers. But the sensitivity analysis completely ignores that. I only change one variable at a time. Because you notice when I changed unit price, that was the only thing I changed. Did it by the plus or minus 10, 20, and 30%. When I was ready to start variable cost, I set unit price back to the original $3.50, and I only changed variable cost per unit. It also assumes that each variable that's uncertain will change, has the same degree of uncertainty. So I changed each variable by plus or minus 10, 20, 30%. But maybe I can lock in some of the variable costs with a long-term contract and only a certain amount of my variable costs are uncertain. So they shouldn't be subjected to as high of a degree of uncertainty. Sensitivity analysis doesn't consider that. It also only considers a limited number of outcomes. In this case, I did 4 uncertain variables and we did 6 deviations from the base case, the plus or minus 10, plus or minus 20, and plus or minus 30. So we looked at 24 potential outcomes in addition to the base case.